Yeah, I'm Philip. Hello, everybody. I'm another one of the software engineers on the Tinkercad team. Thanks to the organizers for having me again. This is my third Block-based summit. Hope you're not tired of me yet. Today, I'm going to showcase some of the new changes we've added to the block-based programming environment in Tinkercad. Well, we've added a brand new feature. It's called Code Block Shapes, and it's out today. You'll get to create shapes in code blocks, like this set of dominoes, arranged in a spiral, and then you can export them to the 3D workspace as parametric shapes with user-defined controls. Tinkercad users will get to develop reusable and flexible shapes to unlock a variety of workflows. And I'm just gonna let this finish out. So I'm just like adjusting it. And sorry for the bad, unsatisfying anvil throw. It's hard to aim in Tinkercad. Shout out to Joshua. Before we get there, here's what we'll cover. We'll briefly explain what code blocks even is for those who are unfamiliar. We'll talk about some of the challenges we had to address this year, and finally, how we went about solving them. Well, what's code blocks? Code blocks is its own workspace in Tinkercad where you can create shapes and transform them, and then combine them using the provided blocks in our toolbox. You'll find a variety of blocks that feel familiar to anyone that's worked in a 3D modeling tool. As for how the code works, we use an imperative programming paradigm in code blocks to match the step-by-step process creators follow in our 3D workspace. After a basic shape block is run, the following commands will operate on that shape. And then when you press play, we'll traverse each of the blocks from top to bottom, and you'll see your design play out on the 3D view. Here's a quick example of where we take some move them accordingly and subtract portions from it to create a simple table. And then you can use variables to adjust the table and leg sizes. We've made a lot of improvements through the years. We've updated the blocks and the block vocabulary to provide more options on how to assemble the shapes. We've updated the UI layout to make it more customizable. We've changed our viewer to be a picture-in-picture experience. So you can resize it, full screen, minimize it, things like that. And then depending where you are in the process, it should allow you to focus better on the code or focus more on the geometry that's being built. We've refined the evaluation and code generation where we pre-process some of the procedures we call templates for flexibility. And I talked about this last year. We added click to run for easy tinkering on different stacks of blocks you have. And then shout out to Joshua again for adding bundles, because that's going to come into play with code block shapes later. And those improvements have paid off. We get around like 20,000 code blocks designs a day created, and our designers are hungry for even more ways to build and share. Teachers are using code blocks more and more as a tool to easily see step-by-step building process of their students. And then since we've released these controls late last year in the code blocks workspace, people have been utilizing it to create more parametric designs, like this drawer system or even this atom generator where you can like kind of decide how many protons, neutrons, electrons, things like that to generate this design. But they weren't able to bring that over to the 3D workspace yet until now. As much as we progressed with code blocks development through the years, we haven't quite been able to complete that full story that we wanted to tell when we first came up with code blocks. There's a clear lack of connection between our workspaces. Today, even if, or not today, well, last week, good save. Last week, you could only send like flattened geometry from code blocks to your shape library, and it's not actually running the code to create the shapes, so it doesn't really feel like code blocks in the 3D workspace. Another challenge that we had was that we inherited this powerful tool called shape generators. It came from the beginnings of Tinkercad, and you could create all sorts of geometry. Shout out to anyone who's made a shape generator before. That's going to be legacy. But maintaining that has become more and more difficult, and especially when we saw the future with code blocks. And lastly, we want to provide a better way to showcase math-driven designs and workflows. Making stairs like this can be easy with our duplication trick, where you just repeatedly apply a transformation matrix. But what if you wanted to adjust the length of the stairs or like the radius of that spiral? You kind of have to like do it all over again. What if you could just change one parameter and then instantly see what that creates? So to tackle that, we came up with a two-phase approach. First, what we released already is controls. where you can make your code blocks designs parametric already, and then bringing that parametric experience to the 3D workspace with code block shapes. Controls provide a simple interface to set input values into your code blocks design, and each control is bound to a variable. The control values work outside the code, so you don't really need to change any of the code as you're manipulating those values. How do we set one up? Here's a quick example. I'm trying to make a forest, and I have a repeat block that's locked into iterating 20 times. Say I want more control of how many trees get planted. I add a variable, number of trees, into the repeat block's number argument. And by default, that variable is going to be 0, so that's going to be 0 trees. But if I set it up with control, I can determine what the initial value is. So then I define a min-max default value for our slider control. And you can even add a label if you want. You can even have it as floating point numbers, but you don't want like a partial tree, right? You want an integer probably. And once that's saved, all these values will be part of the document and saved along with the block XML. We then take the block XML, those control configurations, and the default geometry, and we save it on our backend. And what I mean by default geometry is that we run the code blocks design with the default values that you have defined, and then we save that geometry output into our backend as well. These will now appear in your creations back in the 3D workspace. The block XML allows us to generate our code locally, and the default geometry helps us save time and avoid running any code when you drag that shape out into the 3D work plane initially, which improves perceived performance. The next problem we need to tackle is how to load Blockly and the Blockly workspace without instantiating the entire UI on top of our existing 3D workspace. We found that by leveraging the headless workspace class found in Blockly that we could accomplish just that. With the headless workspace, we can still load our block definitions and extensions, allowing code block designs to be processed in the background. Once we have our design loaded, we can convert that code from code to 3D geometry. And finally, a nice benefit of that is that we can skip all the animations we do in our regular code blocks environment and just show the final result on the work plane. And with all that in place, when you drag out our forest shape, we reference that default geometry first, so it just pops in, and then we skip running the code for the first time, and then when it comes out as a bundle, you can also modify the individual shapes if you want. After a parameter changes, in this case number of trees, we check if all the necessary setup has been done for Blockly and the headless workspace, and then we run the code locally, generate the recipe, and then construct the shapes as you see, and then 3D workspace handles the rest. We can even recognize when there's a random block in your XML to expose a randomize button that lets you rerun the code without changing a parameter value. Here, I set up a parameter that kind of drives a variable and in a block of conditionals, and this helps determine different blocks of code that gets run and then outputs a different primitive shape that we have in our toolbox. This is an easy way to change the objects that show up in your code block shape and but maintain the formation that you're trying to deform in your code blocks design. And then here's a fun one of burgers. That's not released in production, but here's the robotics example that Joshua was aforementioning with our gear code block shape. You can change the number of teeth with a parameter, and then the radius will adjust accordingly. I can quickly run my simulation again with a new gear size without having to model an entirely new gear. So that's been really helpful. And then for one more example before I go, this is our brick wall shape generator. It's a very powerful shape with many variables to adjust, but with the way it currently works, it takes a lot of time as you send all these values over to the server side, and then the user has to kind of wait around until it finally appears with the new values. Instead, I want to show how code block shapes can be just as useful as shape generators when you set up the controls to tweak each variable. I have controls for things like the width of the wall, the height, the depth, even things to adjust some of the noise of like the placement of the bricks. And then when I bring that over to the 3D workspace, we can see how quickly the results appear after we change a parameter. Even with the generated code that can be like many of lines long, if you utilize good practices in creating code block shapes, they can perform faster than shape generators. We're only a week into the launch, so I'm hoping more and more creators will we'll try and share some more reusable shapes. If anybody wants to be a shape author, let me know. We can sign you up. But yeah, if you have any ideas, that'd be great. We have an initial set of shapes, but we're always wanting more, basically. So what's next for us? As you probably saw, we're only using these slider controls to set up, but I'm hoping to expand to more types, like drop-down lists, toggles, and text inputs for authors to like have more flexibility. As we expand our block toolbox, it would be great to support things like string variables and lists so that people can add that into their controls and then have text. Like we want to be able to make a name tag, but we don't want people to just have like one text string the whole time when they're changing their name tag. And then finally, we want to continue asking ourselves what more ways we can have interconnectivity between our editor environments. How can we make it easy to help Tinkercad users make anything? And that's it. Thanks, everybody.
Questions for Philip?
Sorry, just helping to get your steps in. I really love this, and I wish it had existed a few months ago. I've just been doing some 3D design with this, and it's cool. The code blocks aspect of it, have you had an experience of educators using it almost to kind of as instructional things to sort of model the process that, so even not just getting the learners to develop the code block, but actually sort of modeling that process that you go through, because I think that's really important. Just interested if you had any experience of that.
Me personally, no. We have a team that like works on like curriculum and stuff like that. I think we're still trying to figure it out. As more and more teachers latch onto it, they just kind of like the idea that it's using block coding and we have the commands. They can just go like step by step with their students. I don't know, does that answer your question? I might come and
chat with you after that. Yeah, just pick your brains. But yeah, thank you very much. That's
great.
Of
course. Thank you.
Thank you. You asked one question? Yeah.
Hello. So on the App MNR team, one of our engineers is working on an AR/VR extension where right now what we're doing is like you take a picture of something and it uses like AI to do a 3D model. And I think something like this would be amazing for that. So just, it's not a question, but would love to connect you to her.
Yeah. I don't know if you've tried our iPad app, but we have like a specific AR button just there in the 3D workspace environment. And we're hoping to expand on that more. But yeah, we'd love to connect. That'd be great. Thanks, everybody.